Ready? All right. Thanks for coming, everyone. My name is Luke Lee, and I want to talk to you about this theory that I'm trying to come up with on how to write dumb tests and kind of talk to you about some of the problems that I've had when writing smart or clever tests and how hopefully you can avoid them. First off, a little bit about who I am. I work in the oil and gas industry, and I write desktop visualization software using Python and NumPy and all the familiar SciPy Python science stack tools. I'm also a recovering C developer. I spent years writing embedded systems for flash memory. That's a different sad testing story for another day, but we won't talk about that yet. So I want to start things off by telling a story that I'm kind of calling the last day of a sprint. The idea is that I wake up in the morning, it's the last day of a sprint, and I have some ideas for this last feature that I want to get in before the sprint is over. So I get to work early, make some architecture notes, come up with some ideas, and spend a couple hours writing some code. Everything seems to be going okay, and I'm like, okay, well, I'm going to write some unit tests now to verify that what I'm doing is correct. I write a couple unit tests. They seem to pass, albeit not on the first try, because I don't know about you guys, but I never ever trust a test that passes on the first try. So again, this trial and error, I write some tests, and finally I get them all passing. I think my code is ready to go. So then I give it to the user, and they're going to run it overnight on some Linux cluster or some batch process or something. And I'm thinking, all right, I'm going to head out early today. Everything is great. And almost immediately, the user comes back and says they had an exception or something happened. And of course, I look at the data, and I see that, oh, okay, well, the data, I didn't expect it to look exactly like that. It's a little quirky. I'm not handling some things right. So what I did was I told the user what the code said it did and not really what it actually did. And unfortunately, the story doesn't really end here. So at this point, now I've got a bunch of tests written that didn't find a bug, and I've got a real bug, and I need to fix it, and someone's waiting on me at this point. So I fix that bug and write a couple more tests. And then I notice I run all my test suite, and a different test fails. And at this point, I'm like, oh my gosh, this testing stuff is just not worth it. What am I doing here? And what's happening is now I probably have a bug in a test. And a bug in your test code is like the worst type to ever have. And what happens here is subtle in that I start to silently trust my tests less. So whenever a test fails now, I'm going to start debugging my test code, not my actual code. And then I'm going to get this great idea that I'm going to refactor all of my tests. I'm going to make them much nicer. I'm going to build all these nice abstractions and clean things up. And then I start injecting even more bugs into my test code. And this is an infinite cycle. And the bottom line is that this cycle just really sucks. So that's the motivator of this talk. I'm trying to figure out how to get out of that cycle. Has anyone ever been through something like that? Okay, it's reassuring to see a couple of hands. So this is more of like a therapy session, not a confessional, about all the things that I've done wrong. So the reality is that testing and breaking things is a really important part of our job as developers. And I've gotten really good at the breaking part. The testing part, something I'm constantly working on. I'm trying to spend less time debugging tests, spend more time actually finding bugs in real code instead of finding bugs in test code. And so I've been trying to come up with this idea on what I think the problem really is here. And my current theory is that I think my problem is what I'm going to call smart tests. So here are some characteristics of what I call a smart test or a clever test that I've written in the past. So let's dive into each one of these. First off, let's take this simple function to convert a file of space-separated values into a list of name tuples. So you can see here there's not a lot going on. I import collections, I create a name tuple, open the file, and I'm expecting new line separated file with 3 tokens on each line. Really not a lot of code here. So what would a test for this function look like? So here's what a smart test I think would look like that has a bunch of details in it. This is just a sample test that feeds in a file and checks that returned list of named tuples. Notice that when you look here, the test looks really similar to the code it's testing. And that strikes me as odd when I look at it. You know, the trick, so to speak, in the real code was the line.split that expects there's going to be 3 tokens. I'm going to put those into a name tuple. I have that exact same line in my test, so I start to wonder, well, what am I actually testing? The problem here is what I probably did was I looked too closely at the implementation. I have a bad habit of sometimes when I want to write a test, I open up a window with the code I'm testing and open up a fresh Vim editor and start writing the test, and I'm looking right at the code. So if you think about that, you can end up copying bugs from your regular code to your test code, which is like the worst thing ever. And if you'll notice, I don't know if anyone caught it, but there is a bug in the code. I'm not going to handle a line that doesn't have 3 tokens. Things are going to blow up. But luckily, I copied that bug directly into my test code. So I mean, I'm really doing well now. So what's the big problem here? I think this quote actually captures it pretty well. In other words, I looked at the code and made the test do exactly what the code said it did, which is different than testing what it should do. There's a very subtle difference there. And I just think this quote is pretty helpful to try to think about I think something that's a problem with me specifically, and maybe other developers too, is I think I subconsciously don't want to break my code. So when I write a test, I think I sometimes don't actually want to write a test that's going to break it. And that's even worse when I'm looking directly at the code I'm testing. Unfortunately, having too many details in my smart test is not the only problem. Data is another big issue. I work with a lot of reservoir engineers doing data stuff, like data science kind of things, and it turns out it's actually really hard to get example data. So what I do is I end up making my own example data. And the pitfall there is that my data is clean because I'm a programmer and I'm pretty pedantic and I want everything neat and tidy, so I'm not going to make ugly data. Users, it's a different story. Everything is in a completely different format and everything is messy. And so when I create my own data, it doesn't really work. Like my code is going to work against my data. And again, it's that subconsciously trying to not break my code. I know how the code works, so I know how to format the data. The user has the opposite problem. Unfortunately, in the past, I thought like, okay, well, I don't have data. I can't get much example data from users, so I had this great idea. I'm going to start using random data. It's tempting to try to use random data because you think, well, I'm going to load up a bunch of random data and I'm going to test a bunch of different scenarios that I didn't think of. So this is going to be a lot better, right? Turns out, a long story short, is random data sounds like a good idea, but it's really not. Because sometimes random data passes, sometimes it fails, and it really hurts your reproducibility. It leads to something that I like to think of that's pretty common, is the broken window mentality. The idea that you have a house that's really nice, and when you have one broken window, you start to think a little less of the house. It looks a little beat up. And then you don't worry so much about the second broken window or the third window, and before you know it, you have a house full of broken windows. The analogy for testing is the same way. If I have one test that maybe uses random data, and it just fails every now and then, you have the same problem. I start to think, oh, don't worry about that test. That test just fails sometimes. Or in worst case, I will just skip that test. And then it's when one test fails periodically, you just kind of not worry about 2 tests failing, and then it all just kind of snowballs on you. The other problem with random data is how many times you have to run a test that uses random data to verify that it's actually testing anything, or that you've tested it completely. The answer is you don't really know because it's using random data, so you don't necessarily know what values it's picking. How many times do I need to run that test before I know that I'm ready to release? Finally, the last big issue with smart tests is there's just too much software involved. And I wish I had a better solution for this now, but tests suffer from the same problems as production code. It's all just software, which means it's too easy to change, and it's too easy for us as programmers to build up this cognitive overhead and all these abstractions on top of it, or to do too much with our testing frameworks. So let's see an example to get this kind of idea. Here's a pretty standard example with the built-in unit test framework. Now this is a slide full of code, but if you notice there's actually not a lot of testing going on here. This code is more about inheritance and object-oriented programming than it is about testing anything. I have a whole level of indentation devoted to just a class that I don't know that I necessarily need. And for me, when I'm writing code or tests with the unit test framework, I end up thinking way more about how do I reuse test code than how do I actually test anything useful. And to be honest, some of the worst object-oriented code I've ever written was when I was using the unit test framework, because I'm trying to combine all this code. If I'm going to have bugs in my test, I want to at least consolidate those, so I spend a lot of time reusing all this test code and not any time actually testing anything. But it's easy for me to pick on the unit test framework because I don't use it anymore. So let's pick on something that I do use now, which is PyTest. I use PyTest because it's awesome and it makes testing a lot of fun, partially because it has some really cool features like these fixtures you see. This is pretty cool. It uses a decorator. There's a function inside of a function. You know, this seems like really fancy. I'm feeling pretty good about myself as a programmer. The problem, though, is there's a lot of moving pieces here. If I want to use this fixture in a test, I need to know how decorators work. I need to know what a finalizer is. I need to know what this special defining a function inside of a function thing is. What's module? Scope equals module. There's a lot of things going on here. If someone comes to your project, the barrier to contribute and test anything is pretty difficult. So what's the lesson here? Bugs hide in complexity. This lesson is something that we know from our production code. Bugs hide in complexity and leaky abstractions, which our tests commonly have. The story is, you know, we save all our good abstractions for our production code because that's the code that actually has to work, and our tests get what's left over. So then you end up building different abstractions in your test, and the danger with that is you don't deal with those abstractions near as often as you do with your regular code. So every time a test fails or something, you have to relearn those test abstractions, which might be different than the other abstractions in your regular code. So maybe you're thinking, all right, enough already. I need to know really why smart tests are bad. And smart tests are bad because they're hard to debug, but it really boils down to they're bad because you can't trust them and you can't confidently say that you're saved by the tests. When you think about it, the tests are your safety net, and you don't want to waste that safety net by writing a bunch of clever code. There is no safety net for your tests, so try not to require one by writing a bunch of clever code. So that's enough complaining about what's wrong in my world. Let me share with you this guiding principle that I'm trying to come up with for how to fix this situation and write less clever, dumb tests. Dumb tests are smart enough to find bugs, but dumb enough to debug quickly. So this is the kind of driving force that I keep trying to think about when I'm testing code now. I'm trying to not be too clever in my tests. So let's see what I think of as a dumb test. Some attributes of a dumb test that we can look at too. And let's dive into one each a little bit. First, always consider testing with doc tests. They're pretty simple and they're dumb, mostly because they can't really do much. But there's a lot of power in that simplicity. And you won't spend a lot of time debugging a doc test because by the time you're debugging it, you have to move to something else. But doc tests are pretty great because they run inside your code. Anyone can see how they work. And there's just not a lot of debugging you're going to have to do. Unfortunately, doc tests are limited, so they're not going to always be suitable for every kind of project. So let's see, what's another way we can make dumber tests? Well, let's choose data over code. What I mean by that is to use more test data and write less test code. The idea is to use real examples like I mentioned before. It's not always possible because sometimes users don't have example data or you're using proprietary data or something, but I don't know if anyone else has ever noticed this, but I've found that whenever I give someone code that I suspect works, they can find data to use on it. But when I want to write a test, it's somehow all that data just disappears. I don't really know where it goes, but I can always get someone to find data to break something, but I can't get them to use it for a test. So I'm trying to push really hard for that at work, saying, you know, my story that I opened with, that file that broke my naive code, I will ask for that file. I know that they have it, I saw it, and then I will check that in directly into my repository sometimes if the file is not too big. This way, my tests are actually using real data from a real world source, and every time someone checks out my project, they're going to have that sample data. And if you do that, you have a couple of things working for you. You have a good example checked into your documentation. You especially have a good example for that quirky code that handles this input that one user had one time, and you can prove that that code actually needs to exist. And I found that some of the best tests come from user data that's just all sorts of messed up. So another trick that I use, since I deal with NumPy a lot, I might create a test array of known data, perform the calculations manually. I know it sounds archaic, but it does work. Do it manually, and then save that array to a text or a compressed file with the numpy.savetext. And I'll just check that array directly into my repository. Then my test is pretty simple, right? I don't have to do a lot of debugging because I'm concentrating more on the data I'm testing than the code I'm writing. My test is check out the project, read that array that I have, my truth array checked into the project, and then do the calculations, just diff those arrays. And I don't have to do anything. There's not a lot to debug there. Or you can do the same sort of thing with string IO and faking input and output for your files. So when you're using this data over code concept, you're going to end up with a bunch of tests that do nothing but diff anything. So make sure you're not diffing things in your own code if you don't have to. Python has some good libraries, especially if you're on a Windows machine without the diff command. You can use difflib. Difflib is pretty nice. You can give it a list of strings from a file or something, and it'll give you unified diff, a couple of other formats that you can put into your tests. You're not writing that diff code. File compare, kind of the same thing. You can check timestamps and stuff across platforms. Another thing that I specifically do is I deal with binary data, mostly numerical data in the oil and gas industry. And I write a lot of stuff using the HDF5 binary format. So I will read in ASCII data that's in all sorts of crazy old school formats that's been written by like Fortran or something like that. I'll convert that to HDF5, and then all of my applications are talking only HDF5. But all of my data sources technically comes from ASCII to begin with, so I want to write tests for that, right? I want this ASCII to binary HDF5. And writing a test for that usually would look like convert it to HDF5, read each table or each row out of there, and compare it. But if you start to think of this data over code concept, what I can do is I can check that one time exactly manually. I can convert a file, check it in, and then have that HDF5 binary file into my repository directly. And HDF5 has a really cool command called the h5 diff command, which does exactly what it sounds like. It differences HDF5 files. So now I took this complicated test with a bunch of weird logic, and I replaced it with convert it to one HDF5 file in memory, read the one from my repository, run the h5 diff command, and see what happens. Again, there's not a lot to debug there. So after you've chosen to use more data and less code, another thing to consider is testing goals over implementation details. This is a direct response to the SMART tests, which I mentioned had too many details. Let your docs guide your testing. That's what your user is actually going to read. And I found that a lot of times if I start testing on a different day than the day I wrote that production code, it's actually more useful. I have a fresher mind, and I'm not thinking about the details of the code. I'm thinking about what the code says it does. You know, if I read the docs, I'm thinking about what the docs say it does, not what the code says it does, which is pretty important. Another thing is I try to postpone code coverage till pretty late in the testing cycle, because I found that code coverage leads me to thinking too much about the details too early, or it ends up being some kind of achievement game where I'm just trying to execute every line instead of test every line. And again, that's a subtle difference. So I feel like sometimes code coverage can be really useful if you bring it in at the end of the cycle, because then you start to see that maybe I can't execute a couple of lines of this function, and I don't know why that is. And that maybe means I need better example data checked into my repository, or that means that that code is actually not reachable and I don't need it at all. So that's when code coverage becomes important, but I think if you introduce it too early into the cycle, you get caught up into this, let me just execute every line. So what's an example of this goals, not implementations? Let's go back to our earlier example, turning a file into a list of named tuples. Remember that test looked almost exactly like the production code it was testing, and here I don't have any of that stuff. Here it's pretty simple, and like this test doesn't have a lot of smarts. There's not a lot of logic in here that I'm going to have to debug. The function that I'm testing said it would read a file and return a list of tuples. That's all this test actually does. It doesn't actually read that file and split it and copy this logic from the production code. So again, there's almost no logic in here. I don't have to do much to debug this. If this test fails, I'm going to have a pretty good idea that the bug is actually in the production code. And finally, to drive this goals, not implementation concept home, Dave Weiner has a really great quote, one of the early authors of RSS. Think of it like this. Users typically know only what you tell them, so concentrate on what you tell them and feel their pain when what you tell them is confusing or a lie. So if your documentation is lying, use your testing, your docs to guide your testing and feel the pain that your users are going to run into. Finally, the last part about writing dumb tests is to be brave. This might sound strange, but think about it. Imposter syndrome is a real problem. And I myself get worried when I write some code that someone's going to come behind and think I'm a bad programmer or I didn't know what I was doing. But that doesn't have to stop us from writing simple code or these dumb tests that I'm talking about. Be brave enough to keep it simple. Like here's an example. This is again using the PyTest framework. This test uses every single inch of the PyTest framework available. And I'm sure it's going to impress someone with how much I know about the PyTest framework. But if you look at it, what is it actually testing? There's a lot at play here, but it's not really testing anything. And you could write this same test by just having 3 assert statements, right? But I'm not going to impress anybody with those 3 assert statements. So the idea is that there's no shame in you not using every single feature of everything you have. And again, if this test fails, I'm going to have a pretty hard time proving that it's not a test bug. So when you're on the subject of being brave, maybe one of the bravest things you can do in your testing is to replace a test with just an assert statement. A lot of times you'll make a test so dumb that you don't even need it. You just put an assert statement in there, and it's even better because that test, so to speak, is getting run every time your code runs. You don't have to worry about that. Another thing you can do is maybe be brave and remove some tests. Oftentimes you'll have a test that has never ever failed. And I question, if a test has never ever failed, what is it really telling you about your test code? Maybe it's just noise, and maybe it doesn't even need to be there at all. You know, there's a lot of safety to say I have 100 tests and 100 tests passed, but if those tests have never failed, I'd argue maybe they don't even need to be there. So in conclusion, what's a dumb test? A dumb test is one that uses real-world data, focuses on goals and not implementation details, and it lowers the cognitive overhead with brave and simple code. Or in a more snarky, short tone, write boring tests. Here are the places that you can find me if you want to read some of the inspiration for this talk, and where I complain on Twitter and talk on my blog and that sort of thing. Thanks everybody for coming. I'd love to hear any horror or war stories about testing that you have. I think we have maybe time for one more question, so any questions? So my main thing that I work on, the question is, do I have any tips for a GUI? We're testing a GUI. The main thing that I actually work on at work is a GUI application, and that is really challenging. There's all these frameworks out there to do these mouse clicking things and find the window, and then you go to a different machine with a different size monitor and all your tests fail or something like that, you know. So what I found in testing the GUI is I end up writing all the real logic of my code and something that I can call from the command line. And then the GUI is just a veneer on top of that. So most of my tests test the logic and stuff and not the actual GUI. So I haven't found a good way to really test that clicking this button does something, but I haven't found, if you write the code in a way, you can verify that what that button calls gets tested, but not necessarily the clicking of the button. Sure.
How about ideas for boundary conditions?
So like if you can handle data below X or above Y or something like that. I used to think random was a really great way to do that. Bad idea. I don't know if anyone else has ever gone down that rabbit hole. No, I think if you start writing tests that are really simple, though, you can think more about how to deal with that problem. You know, don't think of that as a code problem. Like how do you actually deal with testing that your algorithm doesn't handle a certain set of numbers or something? And you can start to think about how to model that idea instead of how to make a PyTest fixture to generate data that's going to do something weird. You know, think more about what the problem you're actually trying to solve and not the decorations you're going to put around it. Any other questions? All right, thanks everybody.